Hello, I am Berkcan Çalışkan. Today I'm gonna talk about thermistors. Let's start it. What's a thermistor? Thermistor, as the name suggests, is derived from the words thermo and resistor. Thermistors are a type of resistor made of semiconductor material and whose resistance values change with the effect of heat. The temperature and resistance of thermistors are directly related to the material from which they are made. It's known how much temperature change will affect the resistance of the thermistor. Its temperature can be found by measuring the resistance of the thermistor. The thermistors consist of metallic oxides, binders, and stabilizers. It is pressed into a mold and cut at chip sizes. It can be seen in Figure 2. Figure shapes are generally like a disk. Another important point about thermistor is the thermistor types. There are two commonly known types of thermistor. Firstly, the negative temperature coefficient, and secondly, positive temperature coefficient, NTC and PTC. Let's talk about NTC thermistor. In this thermistor, temperature and resistance are inversely proportional. It can be seen in Figure 3, resistance temperature characteristic. If the temperature increases, the resistance of NTC decreases. And also, unlikely, if the temperature decreases, the resistance of the NTC increases. Another important point about NTC thermistor is a beta value. Beta value is a constant and it is depend on characteristics of usage material, and the beta value is used to achieve the appropriate characteristic in an application. Beta is increased, then sensitivity and accuracy decreases. It can be seen NTC thermistor equation: RT, resistance at temperature T; R0, at resistance at temperature T0. T0 is a reference temperature, room temperature 25 Celsius. Beta is a constant, as I said. And another important parameter for NTC sensor is a temperature coefficient. Temperature coefficient can be found by differentiating a thermistor equation with respect to T and dividing by RT. It can be seen that temperature coefficient is a nonlinear function of temperature. Another important parameter of NTC is self-heating. Self-heating occurs when a current flowing through a thermistor. A thermistor is a kind of resistor and it dissipates power as a heat. As more current flow, the heat will grow. Power dissipation it can be seen in Figure 6, current voltage characteristics: 0.1 milliwatt, 1 milliwatt, 10 milliwatt, 100 milliwatt. A positive temperature coefficient thermistor, PTC. Another name of PTC is posistor. PTC thermistors are unlike NTC thermistors. There is a direct proportion between temperature and resistance, and their resistance almost remains constant at the room temperature, 25 Celsius degree. A relationship between temperature and resistance can be seen in Figure 7. Application of thermistor areas. First, the microwave. Thermistors are used in microwave machines to determine and maintain internal temperature. And second one is a circuit protector. Without a thermistor in power supply, surge of energy will be uncontrolled. This could lead to overheating or too much electricity being pushed to whatever is plugged in. Third one is a digital thermometers. In cars, thermistor devices used to gather information rather than helping to maintain temperature. It is used in the system like a feedback component to control interior temperature of a car. Rechargeable batteries. When the batteries start charging, there is a tendency for things to get hot. The low resistance of the thermistor allows it to stop the charging if things are getting too hot. The important application area of thermistor is automotive. Cars, trucks, and buses are all use thermistors. Thermistors in car, trucks, buses do not prevent or regulate. Instead, they are used to gather information. This allows the driver to fix their car or truck before something serious damage happens. And food industry is another application area, and handling and processing of food items is important. Uh, 3D printers and microcontroller system. Microcontroller system, low-cost microcontrollers used with precision interchangeable NTC thermistors provides the design engineer with unlimited design possibilities for temperature measurements and control systems. Biomedical applications of thermistors. The usage of areas of thermistors were shown in the previous section. Another application area of thermistor is a biomedical engineering. Let's talk about details. For example, patient temperature is measured using thermistors that are packaging in variety of probes, such as surface rectal, esophageal, and catheter probes. NTC thermistors are used for measuring flow in inserted devices. A pair of meshed thermistors can be attached to the tip of catheter, which can be guided to different locations of the heart to measure blood flow. NTC thermistors are used in dialysis machine and also use respiratory rate of patients. Thermistors are used to diagnose of sleep disorders. When patient temperature is observed for the diagnosis of a sleep apnea, for example, the use of thermistor provides accurate and reliable results for temperature measurements. High reliability thermistors are used diagnosis of a cancer also. For example, highly sensitive, more reliable, low-cost thermistors are used for an early diagnosis of breast cancer. Fire thermistors, more preferred in biomedical engineering applications. Thermistors are one of the most accurate types of temperature sensors. Thermistor elements are chemically stable. Also, even over many years, its accuracy has changed very little. Thermistors give a good performance against the electrical noise, the important parameter. And thank you for listening to me.